Hello students. In last class we had seen some problems on the banking of the roads. So mainly we had seen the horizontal circular turning, okay, and how the banking can help you to take the turn. All those kind of some problems I think we have seen, okay. Uh, so now guys, the next thing that we have to discuss today is the radius of curvature. Okay, so today guys we are just going to talk about what is the radius of curvature, what is the concept of this, okay, and we will see some problems on that also, okay. So first thing is let me formally mention it, that what does it mean of radius of curvature guys, okay. So we can say guys, suppose, see, if you have any curve guys, okay, if you have any curve, let me make it, because I think otherwise it would be problematic. So guys, this is, let's say, a curve that we are having. So guys, this curve, any part of this curve can be, you can say, you can show that this is the different part of this curve can be the sub part of what are different sizes of circle. Like what I am trying to talk about guys here, let's say, if you see here, this is perfectly, you can say, getting overlapped here on, 1 minute, okay guys, just a minute. Okay, if you see guys, this part of the curve, okay, this part of the curve is guys, guys, you can see it is completely lying on what, this circle of this radius, okay, this radius, let's say r. In the similar fashion guys, we can see that here also, if I draw a circle, okay, and try to fit, okay, just let me guys, let me move this so that I can show you what I'm trying to make it here. Suppose this is the thing guys, if I place it here properly, okay, so you can see here guys that this much part, okay, this much part is completely getting what, overlapped on this size of circle, okay, this size of circle. It means guys, what we can say, that this part of the curve, this part of the curve has a radius of curvature, let's say guys, this is r dash, okay, radius of curvature of magnitude r dash. Similarly guys, this one is having what, of magnitude r, okay, of magnitude r. So I hope you are getting the idea guys, that what does the mean of radius of curvature, okay. So if I formally guys write this thing, that what I have discussed right now, it is basically guys, what the radius of curvature is, it is the size of the size of the circles size of the circles on which any specific segment of a curve can be can be completely get superimposed get superimposed. Okay guys, so that will be known as guys, what the radius of curvature, okay, that will be guys known as what, radius of curvature. Now the question comes guys, that how do we calculate the radius of curvature, okay. So guys, calculation of radius of curvature, okay, so guys, calculation of radius of radius of curvature. Now guys, here we are going to focus now. So guys, see, uh, to calculate the radius of curvature, Guys, see, there are two types of problem statement you will see in front of you. Okay, the case one, okay, the case one, if I talk about the case one is, guys, what, when the in the problem it is given, the equation of the curve, okay, equation of the locus is given to you, and then they ask you that radius of curvature for a general coordinate, can you calculate, or for a specific coordinate if you can calculate. Okay, this is the question. So guys, the in the case of, in the case of where 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 the equation of equation of curve is given, equation of curve is given, guys. Okay, like suppose example, okay guys, suppose if you have y is equal to fx as a function, okay, this is given to you, okay, this is given to you. In that case, guys, okay, if you want to find out the radius of curvature, what you can do, guys, r will be given as 1 plus dy by dx whole square power power 3 by 2 divide by d square by dx square. Okay, so guys, this will be what the radius of curvature. This way we can find it out. Okay, so this is a very general formula. So guys, suppose if you solve this, okay, dy by dx and d square by dx square, you will get a general function of r. Okay, and in that general function, if you put the value of x, okay, you will get a specific radius of curvature for that particular coordinate. Okay, so if you put particular x, guys, you will get a particular radius of curvature for that local segment of the curve. I hope you're getting my point. Like, if suppose, guys, if you have a I'll just first explain this what I am trying to communicate here, and then we can go on the proof of that how this equation have been derived. Okay, generally, guys, you will not see this proof of this, but I'll discuss it here. Okay, I'll discuss it here because then you'll have a much better clarity about this. Okay, so guys, suppose this is a parabola. Okay, this is a parabola that you are having, and uh, this has a, guys, what, a general function y is equal to fx. So guys, suppose this is coordinate x. Okay, this is coordinate x. So guys, here if you want the radius of curvature of this circle, so you can first you will get r as a function of some, let's say, gx. Okay, because you are doing this all this mathematical uh, manipulation, then guys you will get some function of gx, and then guys, suppose here at general x naught, like this x naught value coordinate, you want to find out the radius of curvature. So for this segment, guys, for this segment, we can put this g x naught value here, and then we will get a specific value of what, radius of curvature for this part of the segment of the curve. Okay, so this is the whole thing that I wanted to tell you in this case. Now guys, let's try to see that how we can derive this relationship that I have discussed above, that radius of curvature for a general curve, how we can derive it. Okay, so let me show you the derivation of this case. Okay, so guys, suppose if you have, let's say, guys, let me make a xy coordinate, and suppose, guys, this is some curve. Okay, let me make like this only, so that it becomes a little easier to showcase. Okay, okay, this is some sort of curve that we are having, and suppose, guys, i want to I want to find the this segment. Okay, this segment, the radius of curvature. Okay, I want to find out the this small segment, guys, what is the radius of curvature. Okay, so let me, guys, put it like this way. I'll take this very small segment, okay, and I want to find out the radius of curvature of this. Okay, so guys, what I'll do, I'll draw a circle, okay, which is just touching this. Okay, so if you see, this is what, a circle that we are having. Okay, so guys, let's say this is what guys, this is your line, and this line is guys what, parallel to y-axis. From here guys, I am locating the position of this small segment here guys. This is, let's say, angle theta. Okay, and this guys, of course, because we are moving in this direction, so guys, let's say this segment is having the angle subtended at the center is what guys, d theta. Okay, so now guys, if you see, uh, if I drop a tangent on this segment, okay, if I drop a tangent on this segment like this way, okay, so guys, if you see, this angle will be what, 90 degree. I hope you're getting my point, because this is radius and guys, this is what, tangent, near about tangent guys. Okay, so this is what guys, 90 degree. So this will be what, 90 minus theta. So this will be also guys what, 90 minus theta. So this will be what guys, theta only. I hope you're getting my point. So guys, these two will be what, pi by 2 minus theta. Okay, these two will be what guys, pi by 2 minus theta. I hope you're getting my point. Okay, now guys, if you see this length, let's say if I just make it guys here, this is, let's say guys, dl. Okay, and if you see guys, this, we can say this is x coordinate. Okay, and this is y coordinate, of course. And guys, we have just, we can show this slide, like the slight displacement about this arc length. Okay guys, that arc that we are getting, this is guys, let's say this is what, dx, and this is what guys, dy. Okay, this is dx and this is what, dy, we can say that. And guys, then this will be also what, theta only. I hope you're getting my point. This will be also what guys, theta only, settled. Okay, so now guys, what we can say, if I just go little bit in the calculation, what I can say guys, that this dy by dx will be equal to what guys, theta only, and that we know already. Okay, it's a very basic thing in the differentiation. You had seen this thing in the basic maths. Okay, and now if you see guys, this dl will be equal to what guys, under root of dy square plus dx square. I hope this is also fine guys. Dl will be what guys, dy square plus dx square. Now guys, if you see, this dl can be written as, if I guys take dx out from this square root, so what I can write is this dx into 1 plus dy by dx whole square. Okay guys, this is what, this is your dl. Okay, now guys, if you see, the dl will be what guys, we can replace this dl in terms of what guys, r and d theta. Okay, so let me do that also guys. So guys, we know that if you see, this is a what guys, this is a arc. Okay, this is a arc, and this arc can be written as guys what, r d theta. I hope you're getting my point. So guys, here the radius of curvature rc, let me change the color guys. Okay, so rc into d theta. Okay guys, rc into d theta will be equal to what guys, dl. Okay, so guys, rc will be what, that will be dl by d theta. That will be what guys, dl by d theta. I hope this is settled. Okay, now guys, if you see, okay, here I have done some mistake guys. Okay, this should be what guys, this should be dy by dx should be equal to what guys, tan theta. Okay, so that's my bad. Is this will be what, tan theta. Okay, this will be what guys, tan theta. So now guys, if you see, what do we need, we need that d theta guys. Okay, if we can eliminate d theta in the equation, then I think our job would be done. Okay, so guys, if you see here, what I'm going to do, uh, dy by dx is equal to what guys, tan theta. So guys, now if you see, let me differentiate this. Okay, let me differentiate this. So guys, if you see here, d square by dx square will be what guys, sec square theta into d theta by dx. Okay, d theta by dx. I hope this is okay. Now guys, if you see, the d theta, okay, d theta guys, d theta is equal to what, uh, rc into d theta is equal to what guys, dl. So rc into d theta guys, I can replace with dx plus 1 plus y 1 plus dy by dx the whole square. Okay guys, let me put these values. Okay, so see, dl by d theta, dl by d theta guys. Okay, 1 minute. Dl by d theta is equal to, yes guys, just mathematical manipulations we have to do. So guys, dl by d theta, if I put this, so here I am just differentiating dl by d theta. So guys, it will be what, dx by d theta into under root of 1 plus dy by dx whole square. Okay, and guys, d theta by dx is equal to what, d theta by dx is equal to, yes, let me put that also. So d square by dx square is equal to sec square theta into d theta by dx. So guys, here we want to eliminate the theta. So guys, what we can do, we can do like this. See, d theta by dx can be written as guys what, d theta by dx can be written as is, we want to eliminate this, uh, 1 minute guys. Dl by d theta is equal to r, that is fine guys. How do we eliminate dx by d theta guys? We can do this thing, that dx by d theta is equal to sec square theta divided by d square by dx square, I guess so. This or not guys, dx by d, no no no, yeah, fine guys. So sec square theta divided by d square by dx square. Okay, I think guys, this is what, dx by d theta. If you see guys, just let me show you, the dx will go like this guys. So after that d theta will go in the denominator. So dx by d theta is equal to what guys, sec square theta, and this will come guys in denominator. So this is the thing. So guys, we got dx by d theta. Now guys, replace this value here. So guys, if we replace this value, so r will be equal to what guys, it will be 1 plus tan square theta, sec square theta basically guys, I'm converting into what, 1 plus tan square theta divided by d square by dx square into what guys, 1 plus dy by dx whole square. Okay, now guys, if you see, tan theta guys can be written as what, dy by dx. So it will be what guys, dy by dx whole square power 1 into what guys, 1 plus dy by dx whole square power 1 by 2 divided by what guys, d square by dx square is equal to r. Okay, is equal to what guys, r. So guys, we can write r is equal to 1 plus dy by dx whole square power 3 by 2 divided by d square by dx square. Okay, so guys, if you see, we have just derived the relationship that we had discussed in the top. Okay, so this is a, guys, what, the radius of curvature relationship, to find out the radius of curvature for a general curve. Okay, for a general curve, I hope this is settled now guys. Of course, this is not like a necessary thing to know. Okay, but just for the sake of what, the sanctity of this lectures, okay, that you should know all the things in and out, that how the things are coming. So that's why guys, I have explained this derivation. Okay, but I would advise that please remember this form, okay, this relationship, because it might be used directly in the problems. Okay, it might need it in the problems directly. Okay, so guys, please remember it. Okay, remember it guys. Okay, now guys, coming to the case 2, guys, which is very important, because guys, from here the problems comes, which are like very frequent. Okay, so the problems of this kind of cases guys, we have to understand very clearly. So guys, what is this case? Okay, so here guys, see, the thing is, uh, when a particle is moving when a particle is moving on a certain curve, on a certain curve, certain curve, certain curve with having some acceleration, having some acceleration, okay, having some acceleration, then then to find r, to find r or radius of curvature at some local point, at some local point, we can use use the idea of centripetal condition, centripetal condition, okay, centripetal condition. What does it mean, guys? It means, see, if let's say I'll show you guys here, okay, let's say, let me go on this page. Okay, suppose this is a uh 1 minute, guys. Okay, okay, this is, let's say, some curve, okay, and on this position, guys, you have a certain velocity in this direction, okay, you have a certain velocity in this direction, and guys, let's say the particle has a certain acceleration. Guys, let me choose some other color. This particle has a certain acceleration in this direction. This is the a net, okay, this is the total acceleration, guys, okay. So guys, if you see, this particle is moving on this, let's say, part of the circular element, okay. So if I just make it, guys, with a circle, okay, so guys, if you see, this is moving on this circle. So guys, if this is moving on this circle, it will need, guys, what it will need, a centripetal acceleration. It should have, guys, what, a centripetal acceleration towards the center. Yes or no, guys? Okay, so if you see, guys, it will be having some centripetal acceleration, guys, okay. Just let me make this, guys, okay. 1 minute. Okay, guys, so this will be having, guys, what, some centripetal acceleration, and of course, guys, this centripetal acceleration will be what, a component of the net acceleration, okay. Then only it can perform this like a part of this circular motion, okay. So guys, what we can say, like this, that this will be, guys, let's say, AC, and guys, there would be, of course, a part of this acceleration in this direction, that will be what, guys, AT, okay, which is A tangential, okay. So guys, if anyhow we can, guys, find this AC, if anyhow, if, guys, let's say AC you got, okay, AC you got, so what we can do, guys, we know that the velocity is there, so V square by R should be equal to what, guys, AC. Just talking in terms of magnitude, guys. So V you know, AC you know, so guys, RC will be equal to what, simply V square divided by what, AC, okay. V square divided by what, guys, AC. So this way we can solve this problem, okay. So how do we get, guys, AC? So to get the AC, guys, what you can do, there is very simple thing. What the first thing is, guys, what do you do, you find out AT, okay. AT you can find out, okay. So AT will be what, guys, AT will be, you can take a dot product of A with the V, along the V, and you get a component of vector A along the V, guys, okay. So like, if you see, vector A is given to you, so guys, what we can do, we can write like this, that A dot V cap, okay, A dot V cap will give you what, guys, the AT component, okay. And to do so, guys, what you can do, you know that how to do it, okay. So guys, AT you got. After that, for getting AC, guys, AC vector, you can do this thing, A minus AT, okay. So you got, guys, what, the magnitude of AC vector, okay. So from here you can get what, magnitude of AC vector, and then, guys, you can use this relationship, and you can get what, guys, the your radius of curvature. Okay, so guys, this kind of problems are very very common. Okay, and mostly you will see in your coaching modules or in the books. Okay, whatever platform you are using, you will see that these kind of problems are very very common of finding the radius of curvature. Okay, so guys, this is the second concept, or you can say the second kind of a problem statement that you might see in your like different resources. Okay, so guys, now let me take one simple example, and through that we will guys try to understand the problems to do. Okay, so guys, let's see one problem. Guys, I will take of the first concept or the first situation, and then guys we will take one problem on this second case or the second situation. Okay, so guys, let's see. So suppose guys, the problem one. Okay, problem one, I'll take a very simple problem guys, just to showcase you that how do we use these kind of things. Okay, so guys, suppose if somebody asks you that y is equal to ax square, let's say guys, or maybe let me put some data. Okay, that will be better. So x square minus 4x plus 3 is a curve is given guys, and somebody asks you that find the radius of curvature, radius of curvature 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 at the coordinate 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 uh, guys, let's say if I put 2 here, so this will become what, 4. So this will become what guys, 8. So 4 minus 8 is what guys, minus 4. Minus 4 plus 3, that is what guys, minus 1. So 2 comma minus 1 guys, let's say this is the coordinate guys, and there they are asking that find the radius of curvature. Okay, that what would be the radius of curvature of that local segment which is at near to 2 comma minus 1. Okay, so guys, it's a very simple problem. What we will do, first thing is use the formula guys, that is what, 1 plus dy by dx whole square power 3 by 2 divide by what guys, d square by dx square. So guys, let me first differentiate the function and get a dy by dx value. Okay guys, so as if you see, y is equal to what, it is equal to x square minus 4x plus 3. So guys, dy by dx will be equal to 2x minus 4. Okay, and guys, what about d square y by dx square, that will be guys what, 2. Okay, so guys, we put the values now. So guys, if you see rc general function, if I want to make guys, that will be 1 plus 2x minus 4 whole square power 3 by 2 divided by what guys, 2. So if you see guys, this is a general function of what, radius of curvature, gx. Okay, that we had discussed earlier in the theory part. Okay, now guys, they are asking that what would be the radius of curvature for that local segment, and they have given the coordinate 2 comma minus 1. So we don't need minus 1, of course. We can put the 2 here and we can get the value. So guys, if I put this value, what I'll get, if you see, this will be 1 plus 4 minus 4 square 3 by 2 divided by guys 2. Okay, so it became 0, and guys it will come what, 1 by 2 unit. Okay, 1 by 2 unit. So 0.5 unit guys, whatever the unit you are using, you can use that, and you can like report the data of radius of curvature for that situation. Okay, now guys, I hope you understood that how we should use this formula or this relationship for that kind of problems. Okay, now guys, coming to the different part of the problems, like let's say this is the question guys. Okay, and this is a very standard question that I'm taking now guys, it's very common. So let's see this problem guys also. Problem number 2, based on the situation 2 that we had discussed in the theory. Okay, so guys, problem 2, as it is saying like this, that suppose a particle is performing what, projectile motion. Okay, let's say guys, this is what, a projectile motion, and let's say this angle is what, theta, and this is what guys, this is the your velocity of projection, let's say u. Okay, now guys, the question is, find the, there are three questions guys. First, find the find the RC at starting point. Okay guys, second thing is RC at maximum height, and third is what guys, RC at any general time t on the curve, and of course guys, t should be less than what, time of flight. Okay, t should be what guys, less than time of flight. Okay, guys, let's start with the part 1 of the problem. Okay, part 1 of the problem guys. So if you see here guys, if I, let me choose some darker color guys. So I'll choose a little darker one guys. Okay, now I think that would work. Or should I take this one? Let me take this only guys. Okay, so guys, here if you see, if I draw the the acceleration that the particle is experiencing is what guys, only the gravity. Okay, this is what guys, the gravity, and if you see, this is what guys, theta. So if this is guys the curve that you are going to have, okay, this is the curve that you are going to have here. If you see guys, if I just, let me make this. Okay guys, let's say this is the curve that you are going to have. So guys, of course this should be your centripetal acceleration. Okay, because if you see, this is g, the total acceleration. Okay, and guys, if this is theta, this will be what, this will be guys, the u and the centripetal acceleration should be what, perpendicular to each other guys. So this will be guys, what, this will be pi by 2 minus theta. And guys, if you see, this angle is what, 90 degree. So guys, of course this angle will be what, simply theta. I hope you're getting my point. So guys, what we can say, we can say that the centripetal acceleration component that you need here is what guys, it will be g cos theta. This will be what guys, g cos theta, we can say directly. Okay, we don't need to do any like dot product or anything guys, we can see from here with a simple math. Okay, so guys, what we can say, that AC that you need here is what guys, g cos theta, to perform this part of the circular motion. So guys, what we can say, that v square by rc will be equal to what guys, AC. So guys, from here what we can say, rc will be equal to what, v square divided by g cos theta. Okay, so this will be what guys, the magnitude of the centripetal, sorry, the radius of curvature of this part. Okay, now guys, coming to the second part. Okay, the second part guys, what, at the maximum height. So guys, at the maximum height, if you see, at the maximum height, if you see, in this only I'll make it guys. Okay, so let me just show the diagram first and then we'll go on that. So guys, here if you see, let's say this is the guys, what, this is your maximum height, and this is what, the part of the segment which is performing guys, what, a circular motion. So guys, here if you see, the velocity is what, something like this, and it will be what guys, u cos theta, and g will be of course guys, right now will be perpendicular to the velocity vector. Okay, so guys, here we can say that the velocity vector and the acceleration both are perpendicular guys. It means what, the g means gravity is only guys, what, behaving like your centripetal acceleration in this case. Okay, there is no other component that you can have. So guys, it means to calculate the radius of curvature, we can directly say guys here that, let me remove this guys. Okay, so is here what we can say, that v square divided by rc is equal to AC. So guys, here it means v is how much, u cos theta, so u square cos square theta divided by rc is equal to what guys, g. So guys, rc will be equal to what, u square cos square theta divided by g guys. Okay, so this will be what guys, your RC, radius of curvature, for the maximum height. Now guys, coming to the last part of the problem. Okay, so last part of the problem. So guys, always remember, whenever somebody asks you to calculate the radius of curvature or anything for a general time, it is always recommended, or you can say guys, take it like as it is, whatever I am saying, always think in terms of what is the vector forms. Okay, because without vector form, if you will go you will suffer a lot. Okay, so guys, here what we have to do, we have to use the idea of what, vector form. So let me make the diagram first so that I can show you that how we should approach this problem, and then we will see guys how to do this. Okay, so guys, let's say this is your velocity vector and this is what is theta. Let's say guys, right now at any general time t, the particle is here. So guys, this will be what, your position vector. And guys, of course, it will have some x component and it will have what, some y component. Okay, so guys, now if you see, and this is your velocity. Okay, this is your velocity guys. Okay, so what do you want guys, you want the radius of curvature. Okay, and the g is what guys, in this direction. Okay, g is what guys, in this direction. So now guys, let me show you that how do we calculate the radius of curvature in this case. Okay, so guys, the first thing is, if you see, to calculate the radius of curvature case, first I will write the velocity vector in that term. Okay, so guys, let me write down. Okay, see guys, see, this will be this velocity v will be guys, we can say it will be equal to, or let me do first without vector form. Let me see that guys, can we do it without vector form kya? So guys, if you see, under root of, it will be guys what, u cos theta into t whole square plus is what, u sin theta minus gt whole square. This is what, ux, sorry, vx square plus vy square guys. Okay, I hope you know this thing. So guys, this will be your velocity. Okay, now guys, if you see that let's say guys, this angle that the velocity and g is making guys, let's say this angle is what, alpha. Okay, this angle is what is alpha. Okay, I am calling this angle as what is alpha. So guys, if this angle is alpha, so of course guys, the perpendicular component here that you will have, this will be what guys, this will be, of course, if this is alpha, this will be what guys, this will be 90 minus alpha. So this will be what guys, we can say, uh 1 minute. Hmm, how do we do this guys? Okay, just let me, okay, let's do like this way guys. 1 minute, I think. Suppose guys, this is this angle is what guys, this angle is alpha. Okay, this angle is alpha. Okay, so guys, this will be 90 minus alpha guys. So if I put a perpendicular here with this, so guys, this will be what, this will be pi by 2 minus alpha, and this will be what guys, alpha. Okay, so guys, this will be what, g cos alpha. Okay, this will be what guys, g cos alpha. Now if you see guys, if anyhow I can get alpha, my job is done guys. Okay, this is your velocity at any general time t guys. If we get alpha at any time t guys, then we can do this problem. Okay, so guys, rc will be how much, it will be v square divided by g cos alpha. I hope this is settled. Just we want to guys put the alpha value. Okay, so guys, how do we get the alpha? So guys, if you see here, uh if you see guys, this is velocity vector, this is your guys velocity vector. This is going to be what guys, always u cos theta. I hope you're getting my point. And this vector guys, this is what, this is your uh, what guys, this is your vx, and guys, this is your vy, and that will be u sin theta minus gt. So guys, if this is alpha, if this is alpha, we are calling, so guys, we can say that cos alpha is nothing but cos alpha, because guys, we need cos alpha. Okay, so guys, this is u sin theta minus gt. So guys, cos alpha is nothing but what, vx divided by v. So guys, cos alpha we can replace with the vx by v. So guys, it will be v square divided by g into Vx by V, which is equal to what guys? V cube divided by G. Vx is what guys? U cos theta only. So guys, I think if we want to solve this, we can directly say it is U cos theta into T whole square plus U sin theta minus GT whole square power is what? 3 by 2 divided by G into U cos theta. Okay, guys, this will be what our answer for the radius of curvature. Because if you see, even without using vector also we can deal with this problem. Okay, I hope you understood this part. Okay, I think it should be very clear. Okay, nothing else. Okay, and just let me revise it for you guys. If you see, this is your velocity vector. Okay, this is your what guys? The gravity. Okay, so guys, I assume this is, let's say, horizontal line, and this is what guys? Alpha. If this is alpha, so guys, this will be of course pi by 2 minus alpha, because these two are perpendicular. So guys, if this is pi by 2 minus alpha, and this and AC should be what guys? Perpendicular. This is what AC, let's say. So guys, here if this is velocity, this is AC. So guys, of course this should be what? Alpha, because this is pi by 2 minus alpha, so this will be alpha. So guys, if this is G, so this will be what? G cos alpha. So guys, if anyhow we can get the alpha, we can get directly the radius of curvature. How guys? Because V square by G cos alpha will be our radius of curvature. So guys, to get the G cos alpha, sorry, cos alpha, guys, what I did, I showed the vectors. So guys, this is what your Ux, and this is what guys, sorry, this is Vx, and this is what guys? Vy. Vx will be always the same as U cos theta. So guys, I have mentioned this. And Vy guys, at any time t will be what? U sin theta minus gt. Okay, and this is what guys? Alpha. So if you see, cos alpha will be what guys? If this is the right angle triangle I take, so cos alpha will be what guys? This Vx, which is U cos theta divided by what? V. So I put it the cos alpha here guys, that is Vx by V, which is equal to what? U cos theta divided by V went up guys, that is V cube, and then guys we just put it the values, and that is guys what? The answer of radius of curvature for any general time t. Okay, so guys, I hope you understood the basic idea of what? Radius of curvature. Above this guys, you can build up by yourself, you can take some more illustration, and you can solve by yourself. Maybe in the next class I can take one two more example, and then I'll continue with the what guys? The idea of centrifugal force. Okay, so that we have to cover in the next lecture. So first we will cover that, and then I think we are just left with the vertical circular motion. So after that we will cover the vertical circular motion, and then we'll be done with this chapter. Okay, if something will be left, something that I need to take more, I'll cover that thing, you know, at the end. Okay guys.